So number 5 says write a sentence that describes the set. Remember, unions and intersections are sets. So every single one of these problems should start off with the set of elements in. Okay, every single one of these problems is a set of elements. So it's the set of elements in. The set of elements in, the set of elements in. So I'm going to write that every single time. Now let's think about this. Anytime we see the word the union, we're going to say or. Anytime we see the intersection, we're going to say the word and anytime we say a complement, we're going to say not in a, for instance. So union is the words or, intersection is the word and then if you see a complement, that means not in a set. So let's look at this first one in set A. In set A, it says A union B intersection C. Now that's in parentheses, so we have to emphasize that, which is hard to do in the English language. So it's the set of elements in the set A, and then that's a union, so that's the word or. The union is the word or, right? Okay. And then when we have the parentheses around B intersects C, we have to say both. So it would be or in both B, and then this is the intersection, right? So that's the word and C. So it's the set of elements in A or, and then you wouldn't just say B and C, it has to be both B and C. Let's look at the next one. It says J intersect K complement. So it means it's the set of elements in J, and then intersection is the word and. K complement, remember K complement we would say as not in K. Let's look at 6A. D intersection in parentheses E complement union F. So it's the set of elements in D. Intersection is the word and. Then we have the parentheses around E complement union F. So we're going to have to say both not in E. That would be E complement. The union would be or in F. So it's either not in E or in F. Okay. L complement union M. L complement union M. So it says the set of elements, and then I actually shouldn't have said the word in here because it's not in. So let me go ahead and erase that. It's the set of elements not in L. And then it's a union, or, and then it's M, so we would say or in M. So it's not in L, or maybe I should change this up because the English language is a little difficult here. It is in M. Okay, so it's not in L, or it is in M. So those would be the verbal descriptions of those. I wouldn't ask you to do this on the test. At most, this would be a multiple choice question where you select which one describes this out of words. But I wouldn't have you come up with the words yourself because some of these are a little more sophisticated than I think they need to be. Okay, let's look at the next part. It says Venn diagrams inequality of sets. So this is where we start talking about the different regions of the sets. They're going to use Roman numerals with I's and V's. I hate using Roman numerals, so I'm just going to use consistently a different color. So I'm going to use red, and when I label red and circle it, I'm talking about a region number. Okay? So region 1, which I'll highlight in red here, is what they like, what both A and B like. It's that intersection, right? So if you look at region 1, let me get the pen. Region 1 is in A and it's in B. It's in A and it's in B. So A and B, as we know it, A and B would be A intersect B, because and is an intersection. Let's look at region. We have to look at regions 2, regions 3, and regions 4. So region 2, let me color with blue here. And I want you always to number these regions the same. You're always going to start in the middle and then go to the left and work your way in a clockwise direction. Always start in the middle, go to the left, work your way in a clockwise direction. So region 2 here it's things that are in A, but they're not in B. So they're in A and not in B. So how would we say that? Well, they're in A, so that's A, and would be intersection. Not in B would be B complement. Let's look at region 3 here. Region 3 is the area that's inside of the circle B, but not what they have in common. So region 3 here, what would we say? Well, it's not in A, but it is in B. So it's not in A, that would be A complement, and it's in B, so that would be B, A complement intersect B. And then you have the last region. The last region here is that outside region, right? What's that outside region? Well, it's not in A and it's not in B. So if it's not in A, that would be A complement, and that's intersection. It's not in B, that would be B complement. So there are the ways to describe each, and this isn't the only way to describe those sections or those regions, but those are the most basic. So 1 is what they both like. 2 is what A likes but B doesn't. 3 is what B likes but A doesn't. And 4 is the region that neither of them like. So those would be all the possible regions. And you can see that by reading all of this. That's what they say. They say, like, for instance, region 1 is maybe an element of both A and B. Region 2 is an element of A but not B. So I just put it into the math languages there. Okay? It says, we can use figure 2.1 to determine whether two expressions that involve two sets are equal. For instance, to determine whether A union B, that quantity complement, and A complement intersect B complement are equal sets for all sets A and B, we can find the region or regions each of the expressions represented in figure 2.1. If both expressions are represented by the same regions, then the expressions are equal for all sets A and B. If both expressions are not represented by the same regions, then the expressions are not equal for all sets in A and B. So what the heck just happened? Here's what just happened. If you want to make a statement like A union B complement is equal to or not equal to A complement intersect B complement, the beauty of the Venn diagram is I don't even need to see the sets. What I can just argue is about regions, and that is much, much easier than actually having to go through the elements within the set to determine the answer. So for instance, maybe if I looked at it, one of them was talking about region 2, and the other one was talking about something in region 3. Clearly those aren't equal. Likewise, maybe one of them was talking about region 2, and one of them was talking about both regions 1 and 2. Those are still not equal. So they're only equal if you're talking about the exact same regions. They are not equal if there's any difference in the regions in which you're talking about. So that might have still sounded confusing to you, but here's the idea. Look at it and think about what regions are you talking about. So let's practice with that a little bit. If I said, what regions represent A? What regions represent A? Well, that would be regions 1 and 2, wouldn't it? If I said, what regions represent B? Well, what colors, what are inside of B? That would be regions 1 and 3. Now I'm going to mess with you a little bit. I want you to start thinking, what about A complement? So what regions do not represent A, right? So you would cross off all of A. That crosses off regions 1 and 2. So that would be regions 3 and 4. Think about B complement. What regions represent B complement? Well, B complement would be everything that's not in B. So you would cross off B, which would get rid of regions 1 and 3. So the regions that are not regions 1 and 3 would be the regions 2 and 4. Okay. What if I said A intersect B? What am I talking about? Well, those are elements in region 1. We've already defined that, right? What if I said, for instance, A union B? What would A union B be? Okay. What is A union B? Well, A union B is everything in region 1 and region 2 and region 3. So the idea is get comfortable at looking at these regions, thinking about what areas am I talking about. For instance, what if I said A union B complement? Well, didn't we just say that A union B is regions 1, region 2, and region 3? That's what A union B is. So wouldn't we say the complement of A union B would be the complement of regions 1, 2, and 3? In other words, every region that is not region 1, 2, or 3. Well, what's every region that's not region 1, 2, or 3? That would be region 4. So we would be talking about only elements in region 4. So you're going to do a lot of examples. I want you to get really comfortable with labeling these regions and talking about which region are we looking at. Again, these are region numbers. These are not element numbers. So when we talk about these, I'm not putting the set notation because this isn't a set, this is a region.